colors are different. Do they all different colors?
They're what?
Are they different colors? Did you only assume that
They're different.
Shoot, okay.
They're white, but they're different. Like a white Honda, a white.
Right.
Okay. So this is the last section of this whole book. So it's called the Binomial Theorem. So we're going to learn a few different things today. Okay, so this is called Pascal's triangle. So I'm going to give you the next row, and I'm going to see if you can figure out a pattern here. So the next row is going to be 1, 3, 3, 1. The next row would be 1, 4, 6, 4, 1. Do you have a pattern? Can you do the next row if you think you have the pattern? Did you go 1, 5, 10, 10, 5, and 1? Okay, so you're adding. So the next would be a 1, a 6, 15, 20, 15, 6. Okay. Why? What does this have anything to do with what we've been learning? Okay, so for example, I'm going to take this row that we just did. Where do all those numbers come from? This is 5, choose 0. 5, choose 1. 5, choose 2. 5, choose 3. 5, choose 4. 5, choose 5. That's where all those numbers come from. And it will continue in that pattern. Okay, so for instance, if we were to do the next row would have a 15 in that position. And in the next row, we would be doing 6, choose, because every row switches one up. So 6, choose, 1, 2, or 0, 1, 2, 3, 4. Should be 6, choose 4 in the next row. Let's check that out. Does that hold true? 6, choose 4 is 15. Okay, so that's where that whole pattern comes from. Okay, we're going to start expanding binomials, which is what this is all about. Okay, so this is a binomial x plus y. So if I put it to the 0, my answer is just 1, right? Anything to the 0 is 1. Okay, if I do x plus y to the 1, it'll be x plus y. Okay, we don't normally do this, but I'm going to do it now. 1x plus 1y. We don't normally do that, but I'm going to this time to show you something. Okay, can I do this on the side? Squaring. Okay, so let's square this. So that's what squaring is doing. So first is x squared. You don't need to do this, you can just watch me. xy is the outside, xy is the inside, y squared is the last. Put those together, that's 2xy. Okay, so our answer is 1x squared plus 2xy plus 1y squared. Okay, cubing. You'll never have to do this. I'm just going to show you the long way just so you can see what's happening. So when I cube it, I'm going to take what I did when I squared it. So that was the already squared. And now I have to do another multiply. Okay, so here I go by hand. So don't do this because you'll never have to do it. X cubed plus x squared y plus 2x squared y plus 2xy squared plus y squared x plus y cubed. Okay, see what I did? I just foiled everything through. I can put those together. So 3x squared y. I can put those together. 3xy squareds. So there's my final answer when I foiled it all out. Okay, so we'll write the answer down. So 1x cubed plus 3x squared y's plus 3xy squareds plus y cubed. Okay, I'm done doing the long way because I can figure out what's happening. Okay, what do you notice about what we did in Pascal's triangle and what's happening in this situation? Do you see any connections? The Pascal's triangle is becoming the coefficients. Okay, so the coefficients in the next row should be, I'm going to space them out here, 1, 4, 6, 4, and a 1. Okay, do we notice anything about what's happening with our variables? There's a pattern to our variables. So here, if I look at this line, I went from x squared, x1, no x's. No y's, y to the 1, y squared. Do you see? X cubed, x squared, x1, no x. No y's, 1y, 2, 3. Okay, so this is going to be 1x4. That's it. Plus 4, we got to go down an x, up a y. On the next term, we should have down an x, up a y, down an x, up a y, okay? Plus you don't want to do that by hand, right? That's not something we want to do. Okay, I also know that there's some other things happening. That has an exponent of 4. Do you see how every term the exponents would add to 4? This just has a 4. This has an exponent 3 and 1. That adds to 4. A 2 and a 2 adds to 4. And here's another thing. If this has an exponent 4, how many terms did I end up having when I expanded it? So an exponent 4 is producing 5 terms. Why does it produce 5 terms? When we start our pattern, what do we start counting at? We start counting at 0. So once you start counting at 0, it's always going to add an extra amount. Okay, expand this. So what's going to be the difference between this and this? There's a negative y. Okay, so here's all that's going to change. You're going to alternate positives and negatives. So positive, negative, positive, negative, positive. So that would be the only thing that changes there. Okay, so now we're going to learn this formula that helps us find any term ever. Okay, so okay, here's an example. So if I look at this and I just want to find that term. Okay, so don't write this down, just watch again. 1, 2, 3, 4. It's the fourth term. I'm going to try to figure out what the fourth term is. Okay, I already know the answer. Let's see how to get it using this formula. Okay, so this formula, the NCK is the exponent choose, and since I'm going to find the fourth term, I'm going to choose 3. Now here's why this confuses everybody, because you start counting at 0. Remember this pattern. This is the third term. Look at the choose number. It's 2. Because you start counting at 0, it screws everything up. Everything's going to be 1 less. Okay, so the fourth term, I'm going to take the first part of my binomial, which is x. I'm going to take the second part of my binomial. Okay, now this number is going to match. Okay, and this number is going to be the subtraction. So whatever those are subtracted is that exponent. Okay, so then if I did this in my calculator, 4 choose 3 is 4, x, y cubed. And we got to the answer that we thought we would. Okay. So here is a different binomial. Okay, so here's how the formula would work. So why don't we just jump into finding term 4. Okay, ready? So I'm going to start the exponent choose. Okay, if you want to find the fourth term, then you're going to choose 3. Because the first term had a 0, 1, 2, 3. The fourth term is at 3. The first unit in the binomial is an x squared. And the second unit is 4y cubed. Okay, the exponent on the second part matches the choose number. And the exponent on the first part is the subtraction of your choose numbers. Okay, so in my calculator I'd be doing that. 4 choose 3, 4. X squared to the first is just x squared. Okay, now we have to be careful here. I could see some mistakes happening. Don't forget 4, you're going to have to take cubed. What is 4 cubed? Should be 64. And then y to the, and how do you work with exponents to exponents? What do you do? What's the process there? 9? Okay, so our final answer would be 256x squared y9. Okay, find the fifth term. So, exponent 4, choose. So, if we're going to look for the fifth term, we have to choose one lower to account for starting at 0. X squared, 4y cubed. Those are my units. The last exponent matches that choose number. And the inside exponent is when you subtract those choose numbers. Okay, so now we simplify all the parts. So 4 choose 4 is 1 on your calculator. Anything to the 0 is 1. And then we're going to have to do a 4 to the 4th. So that should be 256. Y to the, did you write 12? That's it. Okay. Let's do this page. Okay, find the fourth term. So, 6 is the exponent. And we're going to choose what? If it's the fourth term, we're going to actually be choosing 3. Okay, we have to pick one less. X cubed, 4y squared. Those are the units in my binomial. Okay, so whatever this choose number is your outside exponent. So that matches. Whatever that is that. And this exponent is the subtraction. So 6 subtract 3, so that has an exponent 3. Okay, so to your calculator, 6 choose 3. So that's 20. This is going to be an x to the 9th. Okay, now don't forget in this unit you're going to have to work with a 4 cubed. Don't forget to cube it. So 4 cubed, we've just done that one, right? 64. Y to the 6th. So that's the fourth term when you expand that all. And you don't want to do that by hand, right? Think about foiling out that whole thing. Okay, find the 7th term. Okay, so 10, choose, because 10 was my exponent. So the exponent 10, choose what? If we're trying to find the 7th term, we're actually going to be choosing a 6. Okay, remember, because the process starts at 0, not 1. 3x squared, negative 4x. So negative this time in there. Okay? Can you figure out the exponents on each little part? Okay, so the last exponent should be a 6. And the inside exponent should be a subtract them, a 4. Okay, so the rest is calculator stuff. So 210 81, don't forget to do that, right? X to the 8th. What do you think about the last term, just looking at it before you're calculating? Would that be positive or negative? Positive, because an even amount. Okay, so get me all of those numbers. Oh, did you get like something big? Anybody match that big number? And you know what? You can put x's together. So x to the 14. Okay, so don't forget your exponent rules. Exponents to exponents multiply. Base with exponent times a base with exponent, you add, right? Okay. Find the 5th term. Okay, so give me your what, choose what. If you're doing the 5th term of this, so what, choose what. So 7 is the exponent. Choosing, if it's the 5th term, I'm going to choose a 4. 2x squared, I don't want you, hope you didn't work too far ahead, I'm going to write this differently. 2x squared is the first unit. And the second unit, I'm going to write like this. Do we understand that concept? Remember, negative exponents are the same as putting it on the bottom, right? Okay, so now the 4 will go on the outside exponent, and the inside would be a 3. Okay, I'll let you work on your own just to finish that one up. Okay, we match? Anybody matching me? Okay. Okay, and the last question is different here. So now, which term, I don't know the term, in this expansion contains an x to the 12th? Okay, so here we're only considering the x stuff. So I'm going to disregard all of the coefficient stuff, all the numbers. I'm only going to look at the x portions. Okay, so I want it to end up with an x to the 12th. From the first unit, I used x to the 5th as the x stuff there. And in the second unit, the x's, can you write that with a negative? Does that make sense? So I'm just taking the x portions, not anything with numbers. Okay, I don't know which term, therefore I don't know this. which means I don't know that. I don't know that. What could I do to get this? What's this one? What do we always do to get this one? What did we do to get this one? Subtracted. Oops, not 12, 8. 8, right? That's where I'm getting that from, 8. Okay, so x12 equals x to the, how do you do that one? 40 minus 5k. Okay, so now what do you do in this situation? What do you do with the exponents? You have to add them. Right? Exponents to exponents, we multiplied. Now those exponents get added. Remember all those rules? Okay, can you see I'm just going to say a statement in math that that number has to equal that number? Does that make sense? You could drop them. I probably would have dropped them before, but I didn't want to confuse you. Okay, so those exponents need to equal each other. So, I don't know, I'm going to subtract 40. But this is not your answer. This is the number for the k. So the question was, which term? So if k is 4, what was the term? It was the 5th term. Okay? Because whatever this value is always 1 lower than the term. That whole 0 starting at 0 just messes up all those numbers. So